So I was looking for an Android TV box to basically be a Raspberry Pi but cheaper, and I knew I'd need about 4 gigs of RAM. So this one and another one I was looking at, this was extremely cheap, one of the cheapest ones available at $25, and it seemed to be, a newer one and capable of doing it. But spoilers, it still doesn't really do web browsing. So originally I was trying to get this, and the guy was out of town, but I did eventually get it. So I don't regret getting the other one, but I think I'm kind of done with these at this point. So what scared me about this was no one was really mentioning using this. There was one instance of somebody for Libra Elect who seemed to have been using it, and I was expecting, parts would not to work, but it turns out that it's potentially completely implemented, and it might be the later version of the 905X3 chipset that was slightly better. So I configured it as that, and that's how I'm using it. So I'll demonstrate its performance before going into how I installed it and some technical issues. I got a free monitor back a little while, and I found out I couldn't really use it as a primary display, but it's very useful for this because it's got built-in audio and sort of a 1 to 2 USB hub, 1 input, 2 output. So that's the setup I'm about to show. So in this game, at least, a larger window resulted in a frame rate that was so low that the game was not really playable. I should point out that there are some games I was hoping would work, like Pioneer Space Simulator, and what appears to be the case is it doesn't meet the OpenGL requirements of those games, so you might be kind of limited in the number of games you can actually play with this. So for a lot of things you could painfully use the web browser, but for example for maps, it's really too slow. And as it goes in, you get these kind of unresolved areas like you see on the right here that never really resolve. They just stay that way. The 2.4 and 5 gig Wi-Fi's do work properly. What happened was I noticed that when I was pushing data out of this box, not receiving it is fine when it was receiving it, but I push it out, I get these SDIO backplane errors. Apparently, the SDIO is a bus that's used for this Wi-Fi module in this case. And I was kind of reading about it. Eventually, I figured out how to change the clock because the clock was at 100 megahertz. And I eventually changed it to 5 megahertz, which might be too low. I don't know if that's going to slow anything else down the computer, but it does work reliably in both receiving and pushing data when you lower it. So one thing that actually worked with the former unit was it worked with my camcorder breakout jack for AV. It's a 4-pin. It has left, right, and ground, and the composite out. And it's either that the wiring is different with this one, which is possible, or there's something wrong with the audio software hardware mix. But at any rate, I did not get it working. I didn't go through every last thing I have to see if I have another cable. Maybe I do, maybe I don't. I don't know. But what I do have is I have 2 of these audio USB dongles, so I could certainly devote one of them to this. And when you do hook it in, like in this picture, I got audio. And what I'm going to demonstrate is the Sunvox music studio, and that does work extremely well. So here I am playing an HD video file, and what I've done is I forced the decoder to use all 4 available CPU threads. So totally implementing all the CPU cores, I do manage to play back HD video. Linux very much probably doesn't support its video features. In the system logs, it was saying that it didn't find a certain firmware file, so it just found like these basic devices and not my Bluetooth player. So I dug up this firmware file on the web and installed it, and then I was able to connect to my Bluetooth player. Here comes a detailed list of things found in my area. So here's a capture of the SSH login, and it was saying before about ZRAM, which is some sort of compressed RAM, and I disabled that when I saw it because I thought it could be slowing things down. I added a few lines to the rc.local, that's a startup file. Mostly it's to change the sdio clock rate so that the Wi-Fi will work properly. So in order to transfer Armbian from an external SD card to the internal flash of the device, you're instructed to run this script that's in the root directory. And one of the problems there is that the root user and the normal user has a slightly different path. And what I thought I'd do is I'd just be root and run it. But when you do that, it malfunctions because some of the things inside are not executed. So although I probably got it working, I decided to do it all over again and change my path. Again, not following their instructions. They use sudo. That might have given you the paths of the other user, the normal user. But what I did is I just changed my path to include sysbin, and then I ran it afterwards. I did it a second time just to make sure I got it. It gives you a few concerning error messages, but it doesn't seem to be working properly. So at the beginning, when this device came from the factory, it's running code from the internal SD card or some chips on the board. And what you want to do, what's convenient to do, is to use the toothpick method, which is a switch at the bottom of the AV jack. You press it, and it starts looking on this one here for some sort of information, or sorry, it looks for something to update itself or something to this effect, but it never satisfies that requirement, so it always tries to boot off here. So that means that you can put an Armbian on the SD card slot device and run it forever. But if you do want to free up that SD card and use, in this case, a 64 gig SD card, you then have to copy from one of these devices, either this device or this device here. You have to copy that to the internal, thereby overwriting the internal SD card and then booting off it. The only problem I found was that initially that worked, but after a while, it wants to boot off this one here, right? So what I did was I have these sort of junker micro SD cards that I got from this lady who's giving them away. They're actually fake. They claim they're really big, like 256 gigabytes, but they're smaller. So they're wraparound SD cards. So if you go up and you write further down the device, it will then erase the early part of the device. So I had reliability concerns that these would just corrupt the data. But what I have done is I have made little fences inside, and just so it would be like a gigabyte or so. Right, and won't wrap around on a gigabyte. They're probably like 32 gigs or 64 gigs, somewhere around there in size. So I write the boot partition here to boot from this particular drive, and then this is where the information I'd like the information to really be is on this drive, ideally. But sometimes it boots from the boot partition, which is the lower end of this one, and I've programmed that to go, manually go into this drive. So in that way, it's stable. Granted, I use a sort of junker SD card. So also, just in general, you'd be very lucky if your system on chip or whatever has a mechanism by which, by a USB port or by Ethernet, there's some sort of low-level thing that allows you to reprogram this and thereby not to de-brick your device. And it's my understanding that this may exist. I didn't have to do it myself because I never got into a situation where I was bricked. So here on the boot partition, here's the part where the kernel arguments are set up. And right now there's a symbolic target, boot target. And for example, what you can do is if you're running on the internal flash, is you can change root equals dev sda. That would be the USB flash stick. Then you'd run off the US flash stick, and you could do things like update your system. So that is in fact what I did, and it did work. It's not documented, but it does work. Thanks for watching.